All right, we're going to continue with quadratics, but today what we're going to do is we're going to looking at different forms of quadratic equations. So what we've been doing so far, we've looked at the vertex form. So for example, an equation like this might be 2 times x minus 1 squared plus 3. So that would tell us that our vertex is at 1, 3, and the 2 would just mean we're stretched out vertically by 2. So what happens though now is we don't always have to write our equation like that. You can see this one here, 2x squared minus 4x plus 5, actually ends up being the exact same equation. So what we have to do is be able to figure out how the other equations work, what they help us with, what they don't, and how to convert back and forth between them. So the one we've been working with we call the vertex form because it basically gives us the vertex. That's why we call it that. So remember our P and Q. So in our formula, our P and Q is where our vertex is. We know the vertex. The A value tells us whether it opens up or down, which gives us a max or a min, and it tells us what the vertical stretch is. So that's all we know from the equation. In order to get x-intercepts, y-intercepts, things like that, we need to either manually calculate them or we would need to graph them. So let's try a quick example. So let's do the one that's on the previous page. So that was 2x minus 1 plus 3. Okay, so from that we know our vertex is at 1, 3. We know we have an A equals 2, which means it opens up and it's going to be a minimum. And from that, that's about all we know. We don't know the x-intercepts or y-intercepts, but we could figure them out. So the y-intercept occurs when x is 0. So we can basically just plug a 0 into our equation. So we get 2 times 1 squared plus 3, which would be 2 plus 3, which is 5. So we know that our y-intercept then would be at, when x is 0, y is 5. So let's go back to that picture and see. And there it is, 0, 5. So that's correct. And our x-intercepts, in this case, we look at the picture, there is none. But mathematically, we'd be able to solve them the same way, but we would just make it when y is 0. So if we plug 0 in for y, so I'll just rewrite it over here, we'd have 2 times x minus 1 squared plus 3. So we could subtract 3 on both sides, divide by 2, and then our next step would be to square root both sides. Because when we go to square root negative 3/2, that doesn't work. We can't do that, so that's why we end up getting none in this case. If that wasn't a negative, if it was positive root 3 over 2, we could square root it, and then we'd actually be able to calculate the x-intercepts. So that's one version. So the vertex form gives us the vertex, and we know the A value. Those are the two sort of key things in that equation. It doesn't give us our x or y. So the factored form is our next one that we're going to look at. And it's written a little bit different. So this one would be, for example, we have something like negative 2 times x minus 2 times x plus 3. So it's still a quadratic, because if we FOILed these things out, it would be x squared and so on. So it's still going to be a quadratic. It's still going to look like the same kind of graph. But in this case, we don't get the vertex. So if we were to actually graph this on your calculator, what it's going to look like is you're going to get a graph that will go upside down through negative 3 and 2 like that for our x-intercepts. So what we're going to do, we're going to spend a big chunk of our quadratic unit dealing with this situation, but for now all we have to understand is it's a different way of writing it. We still have an A of negative 2, so that part we know, our A value still is given to us. But now, instead of the vertex or the y-intercept, we get the x-intercepts. So the way the factored form is, we can see our x-intercepts end up being 2 and negative 3. So they're opposite in the formula, just like it is for the P. But like I said, we're going to focus on this form a little bit more later in detail. But for now, it just gives you an idea that there is a different way of doing it. So the vertex form gives you the vertex. The factored form gives us the x-intercepts. So our last one is going to give us the y-intercept. And the last one is what we would call the standard form, or sometimes it's called general form. And basically that's just when we have our equation written from highest to lowest. So if you remember from grade 10, you would write a linear equation, something like 3x plus 2. That is in standard form. So mx plus b form is standard. So all we're doing now is by having a quadratic, we're adding another x squared term in front of it. So with this one, we still have the same a value again. So our a is still the same, but we don't know the x-intercepts. That's not given to us. But we do know the y-intercept in this case. We have c. So x-intercepts and vertex aren't obviously given to us, but we still have two other bits of information. So for every one of these equations, we kind of get one bit of information. So vertex gives us vertex, factor gives us x-intercepts, standard form gives us y-intercepts. One other thing with the standard form is we can actually calculate the vertex fairly easily, and the formula that's given to you is negative b over 2a. So basically what that means is we can actually calculate our vertex pretty simply. So let's go back, let's look at this other question we had earlier. So our original was 2x squared minus 4x plus 5. So let's work on that one and then we can see if we get it right. So 2x squared minus 4x plus 5. So looking at this equation, we see that a equals 2, that's our front number, and our c equals 5, so that means we have a y-intercept at 0, 5. So we have a coordinate. And now using this new formula, we know that p equals negative b over 2a. So that would be 4 over 2 times 2, which is also 4. So we end up getting a p of 1. So that gives us most of our information. So we know that 1 is our vertex. All we have to do is figure out what our Q value would be. So we've got a couple options. The easiest is just plug that 1 back into the original equation, which in this case is down here. So if we just go y equals 2 times 1 squared minus 4 times 1 plus 5, that'll give us 2 minus 4 plus 5, which is 3. So that means our Q value then is going to be 3. So we'd have a vertex at 1, 3. Okay, so that works pretty good. So if we go back to look at our graph, we already knew that that was the case. We had a vertex at 1, 3, and we just figured that out. So even though we don't get the vertex in the standard form, it's still pretty easy to calculate. So all we have to do is plug it back in. If what we're going to find out later on, another option for this is we could have plugged it into our mx plus b form. So let's just do that. I'll do it on the next page so I got a little bit more room. So remember from our original equation, I'll just rewrite it here. We had y equals 2x squared minus 4x plus 5. Okay, we knew that a was 2. We know that a coordinate was 0, 5. And we just calculated p. P ended up being 2 as well, I think, right? P was 1. So one option we can actually do is we can go right to our vertex form, and that might help us if we need to convert it. So we're going to look at this more tomorrow, but this is another way of doing it. So we get an a of 2, so we can plug 2 in for a. Our coordinate is 0, 5, so we can plug those in for x and y. And we know p is 1. So we could also solve for q this way. So we'd get 5 equals 2 times 1 squared, which is 2, plus q. Subtract 2 on both sides, we get a 3. So from that, we can see that our equation then would be a of 2, x minus p squared, plus q is 3, which is our vertex form that we started with on the original page. So you got a couple options. Once you know the p, plug it in the original, figure out the q, and you're good. That's probably the easier way, or we could go right to this equation and solve it for q as well. So either one will work. So let's do a practice question here. So this one says, figure out the vertex of 2x squared minus 3x plus 4. So once again, let's do the same things. Our a value is 2. Our y-intercept is 4, so that means we have a coordinate at 0, 4. So the only thing we got left to figure out is we need to figure out p. So that's negative b over 2a. So in this case, negative b would be negative of negative 3, which is positive 3. 2 times 2 would give us 4. So we end up with a p of 3/4. So all we need to do is figure out the q. So let's plug 3/4 back into our original. So we get y would equal 2 times 3/4 squared minus 3 times 3/4 plus 4. So if we do that, 3/4 squared is, let's just do this as a decimal, that'll probably be easier. We can do fraction, it doesn't really matter. So we'd have 2 times 9/16 minus 3 times 3 would be 9/4 plus 4. So we end up getting 18/16 minus 9/4 plus 4. Now it's getting a little bit tough to, let's just switch it to decimals now, it really doesn't matter. So 18 divided by 16 minus 9 divided by 4 and plus 4, so that gives us negative 6.125. So our vertex then is at 3/4, or we could write it as 0.75, and our q was negative 6.125. Okay, so that works. And if we really wanted to, we could use the other formula, which might be easier. Let's try it quickly just to see. So instead of using our general form, if we were to switch it to our x minus p form, so we still have 0 and 4 for y. Our a was 2, and p we calculated to be 3/4. So we end up getting 4 equals 2 times 3/4 squared is 9/16. So we get 4 equals 18/16. So 4 minus 18/16 is 2.875. So that's not matching. Let's see what we did wrong here. Okay, so I see it. All I did is I messed up my original calculation over on this side. If we actually type in 18/16 over here, minus 9/4 plus 4, we actually get the same answer. We get the 2.875. So for both of these, we get 2.875. So I just screwed up the first calculation, but it works out the same. So either way, whichever method you like better to get the q will work. And once you have that, you've got your vertex form, and then we could also calculate our vertex formula if we needed it. Okay, our last topic we're going to look at today is how to convert to standard form. So if you get an equation that's in vertex form, or if you get an equation that's in factored form, we want to be able to switch it to standard form. It's pretty simple. We just need to FOIL things out and simplify as much as we can. So remember, if it's in vertex form, when it's squared, that means we have x minus 4 times x minus 4. So what you want to do is FOIL that part out first. So x times x would be x squared. Then we get minus 4x again when we do the inside ones, and then our last ones is 16. So let's just multiply everything by negative 2. So we'd have negative 2x squared. The negative 4x and negative 4x together would be negative 8x times negative 2 would be plus 16. Then we get minus 32 plus 1. So our final simplifying we can do is just put the 32 and the 1 together to give you negative 31. So that would be the equation in standard form. So it's pretty easy, just FOILing things out, nothing too complicated. And if I gave it to you in factored form, it's still the same. FOIL it out again. So x times x is x squared. Then we get a 4x, a minus 2x, and a minus 8. So let's just times all of that by 3. Negative 3, so negative 3x squared. These two together would be 2x, so 2 times negative 3 would be 6x.